All right. Hey, everybody. So this is the first meeting gathering together a bunch of the Scala kernel developers within the Jupyter ecosystem. We're going to just start off and have everybody introduce themselves, where they work, and then kind of what kernel they work on, or kind of what community they work on within that. We can just start off with Alex. We'll go off alphabetically.
Okay, so hi everybody. I'm working on Jupyter Scala, which is Kernel I wrote basically in my free time, but that I'm also using at work. I kind of managed to get to work a bit on it at work, but most of the development is done in my free time. And I've been trying with it to basically have a very light kernel and do all the development in a project on top of a project called Ammonite, which is something in the console. And the idea is to have everything work in a Scala repo in the console and have a small Jupyter kernel on top of it.
Great, thanks, Alex. And then I guess Blue is next, which I imagine is Ryan Blue.
Oh, okay. Nice to meet everyone. Hopefully you can see which one is me because my audio is coming through Kyle. I work at Netflix with Kyle. Currently, we're taking a look at the Tori Scala kernel, and we just released a couple rounds of beta testing to a small set of users. Probably going to open that up further here pretty soon.
Great, thanks, Ryan. Corey?
Yeah, hi, I'm Corey Stubbs. I work at IBM, and I've been working on Apache Tori now for a couple of years, and other Jupyter-related projects here within IBM as well.
Great, thanks, Corey. And Gino?
Hey guys, it's Gino Bustello. Can you guys hear me? Just want to make sure. Yeah. All right. Yeah. So also I work with Corey on Apache Tori as well. We're the creators of the Apache Tori project, and we've also worked on some other Jupyter stuff.
Okay, great. And Joy?
Okay, can you guys hear me?
Yep, loud and clear.
Okay, hi, my name is Joy Chakraborty. I actually work in Bloomberg, and my recent work is actually to use the Jupyter Hub and to secure it basically because we have a Spark cluster, so we have to support a Spark notebook using the Jupyter Hub project and to curverize it. So the kernel that we use is a Spark kernel. The Spark Magic with a Levy. So that's our flow, which starts with Jupyter Hub, Spark Magic, goes to Levy, and then goes to the Hadoop cluster, which is running Spark in the yarn. Now, one of the major focus at this point that I am working, which is basically curverize this entire end-to-end workflow. And I don't know whether if you guys have interest, I recently actually spoke to the Spark Summit East in the Boston about it, like how we did kind of going into the details. So if you want, I can definitely send some references to that. Thank you.
Joy? Next is Marius.
Hi, I'm Marius. I've worked on both Apache Tori and Spylon kernel, which is a meta kernel based Scala kernel, sort of written in pure Python. Mostly ripped up a lot of the sort of ways how you start up a Spark sort of shell, and then it launches it via Py4j. And then that way, it's a very lightweight code base, so that I can reuse all of the IPython code that knows how to talk 0 and Q.
Great, thanks, Marius. Pete?
Hey, I'm Peter Parenti. I'm at MaxPoint. Basically, we're consumers of Scala/Spark kernels. We have a bunch of data scientists, engineers that use Scala, and basically just looking for a good solution.
And then both Tristan and Haley.
Hi, so I'm Tristan. I'm the engineering manager at Cloudera on what we call the data science tools team. I was previously one of the founders behind Sense.io, which a few of you may know. We've worked with a bunch of different kernels at Cloudera, not just Scala and at Sense, not just Scala, but also R and Python. Most recently, we've been doing some work on the Apache Tori kernel. We're using it, but we've looked at a few others. Obviously, Cloudera also has the Libby project, which kind of behind the scenes has its own kernel inside it. So we're just very much interested in how to improve the Spark experience on Hadoop, and Scala is obviously a major player there. And Haley I'll let Haley give her own introduction.
Yeah, not much more, but I'm Haley. I work on Tristan's team as an engineer, and I've been doing a lot of work on implementing and using the Tori kernel within our product.
Great. I think that's everybody. And Jamie, who is Project Jupyter, which appears at the top.
Hi. Yeah. I'm Jamie Whitaker. I'm the technical project manager for Jupyter. Hey, Pete. Pete's on the team. So I'm just here to listen and to take notes for Fernando and to record.
Thank you so much, Jamie.
Thanks, Kyle.
Yes. So this kicks things off. I know for backstory on me, at least, so I'm Kyle, but I guess I emailed all of you, so you know me slightly. I don't actually work in Scala whatsoever, but I work with a lot of users that want to use Scala, and then by extension want to use Spark, or they want to use other libraries or cluster computing environments kind of within Scala as well, whether it be Flink or Sio or whatever. And I really want to make sure that we have a good, cohesive user story. One of the things is I think there's at least a marketing piece that we need to make sure we're doing well for Jupyter in terms of the kernels. To say, oh, these are officially supported. Like, this is the Scala kernel that we're backing. This we're the one where we're pushing resources behind, and try to build together as much as possible. And I think as we were evaluating different kernels, like here at Netflix, like we each had our own opinions. Like I'll be free to go on record that I really enjoyed working with Alex's Jupyter Scala kernel. Brian enjoyed working with the Tori kernel, and it was really like if for someone that's really comfortable with Jupyter had trouble discerning what was the better kernel, I can't imagine how difficult it is for a general user that just wants to get things done. And so that's why I want to bring people together now and hopefully figure out how we can pave a path forward. Well, that's it for me. So let me see. So I guess one question I'm going to pose to folks, and maybe this will be a leading question, and I could possibly have Ryan or another take over it, is that it seems community-wise like Ammonite is the right layer underneath for supporting a really good REPL. Like, it's the right library to use. And like I point out within, like Ammonium is a fork that helped make it easier to build the Scala kernel. And so I'm curious what the Tori developers think about that, or maybe kind of where do people want to take things. So if anybody has opinions on stuff and they want to just start talking.
Yeah, I personally can say from the perspective of Tori, I'm not aware of Ammonite. I think one of the main reasons why we have the REPL that we have in Tori is because we were building on top of the foundation of the Spark REPL, and so we were trying to reuse as much code that we can use from outside the kernel, be it from the Spark project. But I would say that maybe at the time of creation we were not aware of other options, so that's why it is the way it is, right?
Yeah, it seemed to me that the Spark REPL module changes quite a lot. I mean, from version to version. That's why I tried to do without it, and it's actually quite. To my surprise, it was quite straightforward to do without Spark REPL module.
Are we on?
Yep.
So I agree with that. I actually don't really know, the benefits of using Ammonite. It looks like there are probably a few better points to hook into as far as tab completion and things like that. But the main concern I have is, and why we went with Tori for our beta test instead of something like Jupyter Scala, was primarily that a fork of something, maintained entirely by the kernel community probably isn't a good way to go. So I would just suggest that, whatever implementation, either the iScala or iMain, Scala REPL or Ammonite, that we go and depend on that as a third party, because that was a pretty big concern for us.
What license is Ammonite? Just by
MIT, I think.
MIT. Okay.
Yeah. What was the problem? Sorry, I don't remember your name.
Ryan. Ryan Blue.
Okay, sorry. Yeah, you were saying what's wrong with Ammonite? You don't want to depend on it, or
I think it's a big problem.
Or you don't want to use a fork
of Ammonite.
Yeah. The problem is it's a fork. Yeah, I agree. I hope it won't. The changes I made in Ammonium will land in Ammonite at some point.
Well, so what I'm saying is, I think if we want to go with that, then I think we should probably, as a community, make a serious effort to get those changes necessary to run Spark kernels into Ammonite, because I don't think it's sustainable to continue running a fork. And I think those changes have been out for something like 9 months now, if I'm not mistaken. So
if I'm hearing it right, you both agree that we should get the right changes up into Ammonite itself. And so it seems like one action item from this is to kind of align on what, at the very least, addressing or outline what we need to address to get changes into Ammonite from Ammonium, and then we can try to enlist various people to help get that all finished. Would folks agree there?
Yeah, I think that makes sense. The other one that is also clear is that there's more than one implementation of the Jupyter protocol in the Java stack. That's likely not a good idea. So, I mean, it's like Tori does one, and Scala kernel does one, and then there's a whole button, and there's a couple of kernels for like closure and stuff like that, and they also do their own one, having some kind of baseline. This is the Jupyter Java client that you can just use when you're building one of these things. If we can sort of consolidate whatever we have and pull that out, I think that could be a sort of a good consolidation move.
Yeah. Either one has to be written in Java to be used by the Clojure and Scala, but then another, if it's straightforward to write, but then if it's not, maybe it's better to have one implementation per language, like one in Scala, one in Clojure. I don't know which option would be better.
It should be pretty easy to use it should be very easy to use a Java implementation across all of them. As for like a Scala one, probably not if you want to mix it in with other things.
Would some of the reason that people would want them in separate languages is so that the interface itself is idiomatic to Scala or Clojure or Java?
I guess, yeah. I don't really know of people using Java JSON libraries, for example, in Scala. That's the Jackson, but in Scala, from what I know, most people use Scala Scala JSON libraries like Cersei or Argonaut or JSON Forest. It's not too common to use directly Java JSON library. But then maybe if we have a Java library that implements the Jupyter protocol, the JSON library would only be used internally, and maybe it would not be that problem. I guess it's the option. Yeah.
Tristan, were you looking to say something?
Well, so a few different things. Well, I guess one survey question right off the top would be, how many people are using Scala for Spark, Tori is implementation of the Scala kernel, as I understand. Well, their implementation is tightly connected with the Spark kernel, whereas there's other users that aren't interested in Spark necessarily, or maybe Spark is one of many tools. And so I guess one, what do people want? And then two, from the IBM's team's perspective, what are they willing to decouple that a little bit, where they decouple the underlying Scala kernel and then put the Spark on top of that, or how are they thinking about that? Maybe we could just quickly go around. I mean, do people want a Spark specific kernel or an independent kernel? I can answer for ourselves. We're very interested in providing a compelling Spark experience from Scala, from Python, from R, from all the different languages. But we do want to decouple to the degree possible, making Spark, one of many potential tools that you can use. In Scala, that's a little bit less important. In Python, and R, it's critical, because Scala or Spark within Python and R is obviously sort of an optional dependency that data scientists want.
Yeah, this is Joy. I kind of agree that if we can decouple the language-specific part from the framework, like a computing framework like Spark, because somebody could use in the future some other computing framework. So means definitely that's the way, because when we work with the different kernels in the Jupyter side, we are not specifically in the business of coming up with the new kernels. We try to use the one in the market, but we love to have extensibility points and to plug into a different type of backend computing framework, because one of our upcoming project would be to have a kernel that can also talk to a GPU cluster for doing, say, a neural net using TensorFlow or something like that. So as long as we can decouple, definitely that's to me the better way to go.
So
yes,
the slight annoyance with decoupling is mostly in that, like, Spark does slightly weird things with how it wants its classes compiled. So it's sort of there is some specialization around that. I mean, we can definitely work around that, but
Yeah,
there's something.
it can be worked around. I mean,
And actually, that's point. This is why we have chosen I'm not saying that this is the best one, but even I didn't evaluate all the kernels, the Spark Magic and the Livy. Livy, we understood that it is pretty much made specific to Spark related stuff, but on the Spark Magic, it's mostly means to have a visualizations which could be consistent. The user experience would be consistent across different programming language, across different backend computing framework, which could take care by a project like Livy. So that's why kind of, to me, that's the decoupled part that I was talking about. Even though currently Spark Magic is made specifically for Livy. It means that's what I am aware that it works for as of today.
And so one other thing within Apache Tori is that its support for PySpark and Spark R, basically R and Python interfaces, not just a Scala interface, but also an R and Python interface. One thing that we've struggled with at Cloudera in terms of the Jupyter ecosystem, especially compared to, say, the Zeppelin ecosystem. So the Zeppelin ecosystem, there's kind of one repository, all the kernels, effectively, although their idea of a kernel or interpreter is a little bit different, but it's all sort of in one central place, and the whole community is collaborating around that. One thing that's a little bit challenging for us at Cloudera is because of the fragmentation in kernels, not just with respect to Scala, but also with respect to other languages, it's hard to bring them all together and say, okay, if we want to recommend Jupyter, particularly attached to a Hadoop cluster, how that would, what would that look like? Is Apache? I mean, one approach would be to have so two different approaches. In this conversation, we're talking about Scala. And so, that in that context, for Apache Tori, we might think, okay, well, we really want to make Apache Tori, first and foremost, be a Scala kernel that has some Spark capabilities on it. A different way of looking at Apache Tori is, no, we actually want, let's say an R, Python, and Scala kernel that's supported by the community, hopefully leverages other, kernels underneath the hood, or doesn't fork the community, and then maybe does some layering on top of Spark. So make sure that we can inject the Spark context into sessions, make sure we can hook up and get progress and cancellation and things that we want from a user experience. Does the IBM team have any sort of thoughts on, where they see Tori going, or where they would like it to go, or?
Yeah. So let me give you a couple of answers to a lot of the questions that you put out. Actually, first of all, I'm very, very glad to hear a lot of you guys have tried Tori, right? That's great. One of the focus points of us is to build community so that we can answer all these questions and actually make Tori what people want to do, right? Now, back to your original question, the original reasoning behind creating Tori was really about access to Spark. And the best access to Spark 3 years ago was through Scala. And there was no Scala, and actually access through Spark interactively. So we wanted to use Jupyter to access Spark. And the best API for Spark was Scala, and there was no Scala kernel. So we wrote Tori initially to have full access to the Spark APIs through a Jupyter notebook. That was its main reasoning, right? Including streaming, which is something that was not there for Python at the time. So that might make the conversation about decoupling Scala and Spark a little bit harder, because the original reasoning of Tori was to be access to Spark. Can it be done? Sure, it can be done, right? Now, to your other question around how there's a Python and R support inside Tori. So that's still, I consider that very experimental. And to a certain extent, my personal opinion is that you're better served with using the standard Python kernel with PySpark support on Jupyter that you would ever be with whatever we do in Scala by burying Python behind the scenes. You're not going to get all the bells and whistles that you get from the Python kernel, right? So that's you lose support there. So I don't know if the best answer to have a cross-language ecosystem around Spark is to embed every single kernel, but rather build a list of accepted sort of interfaces or APIs or things that you want to see, and have all the kernels implement them, right? Some sort of best practices around that, and keep the kernels, because the great thing about the Python kernel is that it's super feature rich. You can do a lot of things that data scientists already do without connecting to Spark. And you cannot do that in the PySpark support that's inside Tori at the moment. It's sort of limited to accessing Spark.
Right, absolutely.
So one point out of this, I think, is that some of the difficulty with, and this from a user experience standpoint, some of the difficulty with Spark is that the interfaces for interacting that with them, visualizations afterward and everything else is not the same across when you're working in Scala or PySpark. Same for kind of how you boot up the setup. And at least for me and Ryan, the way that we set up both Python and R, but R with Sparkly R, is that we actually init, like we provide the Spark environment on demand, and then we have a kernel which is literally the IPython kernel, but with a startup script, and that startup script is the same as the Spark shell, effectively what happens when you run PySpark. But it's still Python. Like, you can actually run this stuff on demand too.
And even with the Scala kernel, we're trying to decouple that. So I've put up a few pull requests recently where it's moving the Spark integration with the Scala kernel so that it's all lazy. It just grabs whatever Spark kernel happens to be there. And we've got it now so that by default, you don't even get a Spark context. We initialize the Spark context when you say, Spark, or you reference where your context should be. And I think we would probably want to go that direction with Python as well, so that our kernels aren't Spark specific. It's just that we know how to boot Spark and talk to the cluster when you need it.
And I think that probably a difficulty for us is because I say difficulty from the community, like for folks like us, is that because we're a large organization and they have folks like me and Ryan, we'll make it easy here, but we know that it's not necessarily easy outside. And so part of the stuff that Tori did actually made it easy for a lot of people to get started really quick. And that's worth acknowledging. And so we're hoping that we can get it towards like this like a really good Scala experience, while still figuring out what's going to make that easy path.
These pull requests are up where? Internally or on the Apache Tori GitHub?
They're on Apache Tori. I've myself, Chip, and Gina have been looking at them and like merging them in. So,
Haley will look at that. Because we've been interested in that exact type of thing as well. We currently use the full IPython and R kernels, and so the Scala one is a little bit different from a workflow perspective because it forces you to have that Spark context. So from our kind of a user experience perspective, lazy sounds more consistent with what we're doing in R and Python.
Yeah, so Spylon kernel is also quite lazy about that. So Spylon kernel is also lazy, and because it builds on meta-kernel, it should be relatively simple adding in additional languages. So anything that has a meta-kernel implementation is probably fairly easy to bind in. I think there's an R meta-kernel around there, but so you can actually get like Scala and Python support with full tab completion for both of those, and that's sort of baked in out of the box. And it's smaller.
Well, one question I have about Tori is that it supports several Spark versions, or because when if you just have to switch to I don't know, newer Scala version, Spark version, or anything.
No, definitely not.
Yeah, that's the thing. Yeah, with Jupyter Scala, we can do that. The way it uses ammonites makes it. It's made so that it doesn't depend directly on Spark, and we add support for Spark on the fly somehow.
So we took a look at the way Jupyter Scala initializes Spark and interacts with it, and we really liked Tori because that sort of thing isn't all that important to us, and it was sort of overshadowed by other concerns. So for us, we deliver based on the version of Tori that you select. We deliver a compatible Spark version. So it doesn't really matter to us that we could use the exact same binaries with different binaries for Spark versions.
Okay.
And I imagine it's the same for other people as well. I don't know, like CDH probably would deliver a single version.
Yeah, from my perspective, we always have to think about from the angle of the end user, right? So the end user, unless they're going to have a workflow that requires to access 2 different versions of Spark, what do they care whether they're 2 separate kernels or one kernel that does it all, right? So the new versions of Spark might introduce new features that we can leverage in the kernel, make that kernel a little bit more featureful than another one, etc. But at the end, the end user using the notebook, if they get the right kernel at that point, they're happy, right?
The other thing that I think is particularly important, for the Scala / Spark kernel space is the question of sort of visualization, and I really like the sort of the idea of having sort of MIME types that output given a hunk of JSON know how to draw a pretty chart or something like that, making that stuff sort of sit slightly closer into core Jupyter and not just in whatever crazy stuff Carl's working on, would make it a lot easier to build some basic visualization stuff, because right now the visualization side of things on the Scala side is pretty poor, right? It's kind of awful. So it's like you can run your stuff, but the instant you want to plot something, it's just like, well, let me just go back to Python land.
So I can speak to that both from a Jupyter angle and of course, like you already said, from like the Interact angle, right? So the 2 main I guess plotting frameworks that are available from like a declarative standpoint are Vega through Vegas, at least on the Scala side, and then Plotly Scala, and both of those do their own way of embedding the outputs, and it's fairly fast for us to iterate on adding in a new MIME type and then trying it out, at least for what we deploy through Interact, and then also for what for now, after the stuff that Grant Nestor has recently done in terms of making it so that you could override the outputs, so that we can start adding in new custom types for Jupyter. So I think at least in Jupyter Notebook, now that Vega itself is starting to stabilize, we can start supporting that one out of the box. And I think like GeoJSON and Vega at the very least should get supported out of Jupyter. I'm not saying that like it's going to be. I'm just like I think we need to aim towards those 2, and I think this dovetails a little bit into at least where we need to head for things like progress bars and stuff that tell you about cluster computing. We need to start establishing a standard. So whatever JSON format that we want to end up with in the outputs, like we establish what the schema is, call it V1, and then we'll start iterating with it, and make that the version that we're going to iterate on within the Jupyter ecosystem in general, so that any of the kernels can use that kind of computational context or cluster context output.
Yeah, I like the direction of thinking about things like Vega. I'll just throw a third one out there because I know about it. It's called Brunel, and it's also open source, BRUNEL, and it's built as a magic, but it actually has support for Tori, and so I've seen lots of demos of it. I personally have used it very little, but I've seen loads of demonstrations of it running on Tori. And it generates pretty nice looking graphs. But that would be probably, I would say that would be probably another community to involve in the discussion, because they're very interested in visualizations in general and visualizations in the notebook.
Is there any standardization currently across, and I apologize for my ignorance, across the Jupyter kernels around, like 2HTML, basically the representation, MIME type, whether it's a, JSON with, MIME type, or whether it's HTML or text. But, I think it would be very important that, there's a million visualization libraries out there. The key thing about Jupyter, Python Jupyter, is that it allows library authors to build these representations themselves, and that the notebooks themselves don't need to implement this functionality. So that definitely needs to be standardized across the kernels within Scala, so that the kernels will know, okay, if I have this type of object at the prompt, I might want to display it. And ideally also have certain, like the display function or the HTML function in IPython, the equivalent, to send the equivalent messages within Scala.
Are you asking about the MIME types or the ways in which you can inspect an object or convert it to HTML, kind of with the display? Like, is it the library side on the kernel?
It's the way you would inspect objects. I mean, the key thing is that I want to make sure that the library authors, a library author in Java or Scala can write a visualization library and just say that if I'm in a notebook, I will do this fancy stuff. Namely, I will, if you just show me the plot object, or put the plot object at, the kernel would typically call like to.html or some to representation and get the representation of that object, and then we could embed it. That would be the interactive use case. The second one would be if you are obviously calling display or actually sending that message explicitly. But
I agree.
The thing is to enable the live. I think all visualization should be done in third-party. Within third-party libraries, not within the kernels themselves, and maybe within some of the notebooks. I do think some standardization of common data frames can be useful with MIME types within the notebook implementation. But that's dangerous because then it's true that then some notebook interfaces show it, like Interact might show it and Jupyter might not show it, and so it depends on the capabilities of the front end whether it supports that MIME type.
Yeah. So for HTML. And generally, a front end is supposed to just render it. But some libraries choose to put in JavaScript that is going to explicitly use a specific version of the JavaScript API in terms of whether it was the old IPython API or the Jupyter API, or what's available through Require.js or whatnot. And I think those ones are difficult, but I think generally, if people assume that their HTML output is actually inside of an iframe, as in so if it's inside an iframe, then we know that it can be rendered on the notebook viewer and other places, and we have a fairly reliable sense about it, which means that there's not a custom MIME type to it. I mean, you have to build your own HTML structure, and then that's what you dump out. And I think the important thing there, like you were saying, is that if libraries are able to use these tools and we give them the right low-level building blocks and then show them how to work with them, they'll be the ones that end up promoting the overall project. I mean, that's one of the big reasons that Jupyter did well was because of, at least for pandas just had to figure out how to do the HTML tables and then took off from there. So
important.
Exactly.
Us to standardize the way that you inspect objects in JVM languages. That standard exists in Python, but we don't really have a way to say, okay, this object was the output of a cell. How do we do anything with it? So that prevents third-party authors from, implementing that standard or registering code. And it's a bit more difficult because using reflection to call in Java, well, Scala at least changes every Scala version. It's not all that, it's not great in Java. So we put up a pull request on the Tori side that has just an example that we're currently using, that you just register a display function. I would love to just put out an API that is kernel neutral, that says, hey, if you're a JVM language and you want to inspect an object, and you want a kernel to be able to inspect your objects, then register a function with this, and the kernel will be able to use it.
So I've got a bit of a question on I guess, direction within the projects here. So, because we're coming up on time, we've talked about a bunch of different directions, and I wanted to offer to make an organization so people could at least work within one GitHub org. But then I realized for Apache purposes, you may end up wanting to be somewhere else. And maybe it's actually a benefit to have more things into one repository rather than split across multiple repositories in an org. I'd like feedback on that, because at least I want to make sure that we get people kind of collaborating in the same spot if possible, and maybe across some of these different avenues where we have interest, in terms of standardizing effectively the repers, the library for interacting with the Jupyter protocol itself. I mean, each is like kind of these standalone things. I'm curious what people think. Like, what would make it most effective for you as a collaborator to work with each other for each of these initiatives?
Just oh, go ahead, Jim.
Go ahead, Corey. Go ahead. I want to hear what you have to say.
For me, I would find isolating the projects separately into different repos would be beneficial. That way, if there's any dependencies on each other, they can have their own life cycles and get pulled in that way. But just coming to mind, I'm wondering if this might be something that would be beneficial to put maybe potentially in the Jupyter incubator org. I don't know if that makes sense, or if it's something that lives outside there on its own. Just throwing it out there as an idea.
Speaking as a Jupyter rep, I will certainly sponsor it. Or Peter will.
Yes, Pete.
There you go. You're on task now.
I've been volunteered, though I said nothing.
Okay. And I guess it sounds like.
I guess the key thing we probably want to put up there is sort of, some kind of design docs on like exactly what we want to sort of pull out of these various disparate projects, and say it's like this is some kind of unified piece that we all sort of share. Just basically like, for starters, the Jupyter Java client, or whatever the hell we want to call it, and then also the specification of what is the equivalent to under wrapper HTML.
Yeah, I think putting a roadmap would be helpful because we discussed so many things. Then we can at least add also to that.
Just taking some quick notes. So it sounds like so we'll end up creating a roadmap for each of these, the Java library, standardization on the wrappers, and effectively kind of a maybe it'll just be an issue, at least for now, in either in the enhancement proposals or wherever we need to end up putting things, to kind of like state our intent for unifying some of the Scala stuff within Jupyter. Yeah.
Yeah, the progress stuff that Dask is doing at the moment looks quite nice. I figure we should just use that.
Cool. So I guess I'm going to ask for volunteers on a couple of these. The first one, I guess, will be standardization of wrappers of inspecting objects within Java, to kind of put up a straw man proposal of what you want to see. I think this will end up within enhancement proposals. I'll send out an email again, but Yeah.
I can do that since we have a partial implementation, at least one that we're using.
Okay. Cool. And then the other one is the Java library for the Jupyter protocols.
I could volunteer for that one.
All right, that was Corey.
Yep.
And then any others that we're gonna kick off here? The main, like an area for the Scala kernel. Once we have those two, I guess what's next? I guess so. The important thing there, maybe because we're doing the reppers as kind of like this is our standard, it would be this is our standard that we can support across multiple kernels. Is that what people are thinking, or are they just wanting to standardize it within?
I think the reppers are critical to standardize across kernels, because kernel, if they're not standardized, then having multiple kernels basically breaks the ecosystem, because library developers can't target anything. It'd be nice if we all came together around one kernel, but if the things were pretty standard, if there's little semantic differences around autocomplete and stuff, that's less important. From our perspective, there's a bigger issue of kernel centralization. It would be terrific within Jupyter if there was a way that we could incubate and bring in kernels as fully supported kernels, starting with the most popular ones, which is R, Python. I mean, Python obviously already exists within the main project, but then also R, and then in R, from our perspective, Scala as well. But there'll be some process to do that. I do think that the fragmentation of kernels it makes it harder for large enterprises to adopt them, and then figure out how to contribute back to them. But that's kind of a bigger picture, desire. So, and I, kind of compare our community to where Zeppelin is, and I just want to make sure that we don't kind of fall behind like that on that front either.
That's a good point. It would also be nice just to have all of the work done that's necessary, a necessary byproduct of that, like having the licenses documented and published, things like that.
Exactly.
For Apache Tori, it's there, and we didn't have to worry about it.
Right. Yeah, I mean, I gotta go on the record and just, basically, I don't understand the focus on focusing on just the repper, basically because from the perspective of the user of the notebook, they're just executing Scala and they don't really see that what the repper is doing behind the scenes. Now, I will agree that one repper might be better than the other, and if you change it from under the covers, you get better performance, et cetera, et cetera, et cetera. But the actual standardizing on the repper, I don't see that value popping up to the end user. I might be off target here, and you guys can correct me. But
what do you mean by repper? Because I thought that was just how you
REPL. Sorry, the REPL.
Oh, REPL. Okay.
Sorry, I got 3 kids in my car right now, and so I'm juggling too many things. So the standardizing on the REPL is it's something that at the end the end user doesn't really see in the notebook that much, and also I don't know if even library creators see it. What they end up seeing is more high-level APIs that are. Excuse me, guys.
Yeah, sorry, I think there's a miscommunication here. I think we're talking about the representation, the display representation. Standardize that. Standardize the way that the way that library authors would implement a representation of their objects. Am I right?
Oh, okay. I got it now. Got confused. Sorry.
I would play devil's advocate on your other point that the REPL does matter, because things like tab completion, code completeness checks, those are functions that are handled by the REPL, and we want those to be very rich. Right now, I see it as there's really only one repper that works, right? We've got the published Scala REPL. Sorry, I'm confusing the two terms as well. We've got the published Scala REPL, and we also have a fork of Ammonite. And for us, a fork of a project just is a pretty much a non-starter because of the risk involved in maintaining it ourselves. So I think it does matter, and I would love to see standardization there. If we can work with the community to get the changes necessary in the fork of Ammonite into Ammonite proper, then that would give us a lot more flexibility.
I think that will come. It just not a matter of time, but the fork uses another library of mine that the maintainer of Ammonite want to see go into 1.0 before using it. And, but it will come. I mean, sorry.
Yeah, that's Corsair.
Yeah. So I think, but the change in the fork will land at some point in Ammonite in one form or another.
So I guess maybe what's important here, Alex, is it would probably be good to help outline what you think needs to be done to get towards that, so that Ryan and others can go to town on helping to close that gap and finish it.
Yeah, for now the main point is having Corsair 1.0 out, so that Ammonite can use it, and that will make the diff between the fork and Ammonite a lot smaller. And then we just have to convince Li Haoyi, the maintainer of Ammonite, to merge the remaining changes, which have to see with low-level stuff like class wrapping. I don't know if you see what I mean. I mean, it's a bunch of low-level stuff, and we just have to make a clean PRs so that he'll be fine with them. I know he wants to use Corsair 1.0 for the. Sorry.
Sorry, I didn't mean to interrupt.
Yeah. I know he wants to use Corsair 1.0 and then we'll have to condense it. Yeah.
So you're saying that just knowing the blockers,
just knowing what the blockers are between for using the Ammonite kernel, REPL with Scala or Spark, I cannot speak today, would be huge, because I followed the thread where you replied to the Ammonite community and said, "Oh, I had to do this and this, and there was probably other stuff." It would be awesome to know what all you had to do to make it work.
Just look at the. I mean, okay, it's a bit. Just look at the commits of ammonium. I should have, each of them. I should have tagged each of them with. So there aren't that many commits. The diff isn't that large. Yeah.
Because if I went and looked at the commits, and they are tagged, but it's not clear how to rebase those on the current version of ammonia or Ammonite. It's also not clear why all of those changes were made. It's just not something that someone else can pick up and run with. So if we understand the overall changes that were done to make it compatible with Spark, then I think we're in a lot better position to understand what you've done and contribute it back to the Ammonite community.
Okay. I mean, it mostly revolves around dependency management and wrapping stuff in classes, wrapping what the user type in classes rather than in singletons. It's quite low-level stuff.
Great.
Okay. It sounds like the action item for this then is probably an issue with a checklist, so that we know what pieces we're gonna close down on. So I'll at least leave that up, and then we can figure out some of the more details within it.
And just more generally about what we're speaking. I mean, what if we close the gap between my fork of Ammonite and mainline Ammonite, I mean, would at some point, I don't know, maybe Tori, could Tori maybe use Ammonite at some point or something like this, or?
I can probably make Spylon kernel use Ammonite very easily because it's not a lot of code. So it's like, because I don't need to do a lot of complicated pieces for that one, mostly because like it's like I assume starting up an Ammonite REPL gives you something that's gives you something similar to an iMain when you're done with it. So once I have that, it's easy.
I think Tori could be modified fairly easily as well. Just adding a different interpreter implementation. I think
very quick, Apache Tori is not really about the REPL. So if someone can figure out how to put a better REPL in there, better.
Kyle, thanks for putting this together.
Oh, yeah, I'm just gonna walk to another section. Yeah, no, thank you all for coming.
You're getting booted, I assume?
Yes.
Thank you.
I'll walk to another place here. Yeah, so anyways, I'll get the notes posted and we'll get the video online, and then yeah, we'll go from there.
Yeah, cool. Thanks a lot.
Okay, thank you.
Guys.